Good morning, everyone. Welcome to this video lecture series on wireless cellular and 4G LTE. Module number 3, lecture number 2 on channel structure of LTE. Now, in this particular channel structure of LTE, we will be going to study about the network architecture and the radio interface protocol. In the previous video lecture, we have seen about how the LTE is been helpful in radio access network architecture, and in that particular architecture, we have seen how the LTE has been categorized into different design principles, or simply you can call it as a design mechanisms, where using all those design mechanism, the structure of LTE, that is channel structure of LTE, is designed. Okay, now that was with respect to the design principles of the LTE part. Now today we will go into the another architecture here, that is the network architecture, with again it will be related to LTE. Okay, and other than that, we have the another a very important protocol, that is the radio interface protocol. Okay, so based on this particular radio interface protocol, we do have some kind of analysis, we have some kind of structures. Okay, so based on that particular structure, we will try to understand how this will help in achieving the network or LTE design. Okay, now in this particular figure number 6.2, which shows the LTE end-to-end network architecture. Okay, so if you look at this particular architecture, this is a one kind of a network which where all the blocks are interconnected with each other with some or the other gateways or some kind of routers. Okay, some kind of the packet data network. Okay, and some kind of user equipments. Okay, and like you have two type of very important interfaces in the mobility management, right? That is S1 interface and the S2 interface. Okay, so using all these various blocks of the network, here it shows how the LTE is connected to, that is connected end to end in this particular network architecture. Okay, so in this network architecture there are various components are there, and these all the entire network, and they are making use of the radio access network. Okay, and also the core network. Okay, so here you can see there are two different control architectures are shown here. One is called as EPC. Okay, and the another is for UTRA, that is Universal Telecommunication Radio Access Network. Okay, so here, making use of these two networks, okay, we try to construct the network architectures. Okay, and using these networks only, we'll try to define some of the new components which are connected end to end, where it can be in terms of you can see here that is a release 8, okay, of the 3GPP specification. Okay, what does this mean here is the from LTE, what we have seen in the previous, which makes use of this UMTS, that is very important and very popular type of telecommunication service. Okay, and that is universal mode. Okay, so that is universal mode telecommunication services. Okay, where that will define some kind of radio access networks, though it will define. Okay, but the same thing cannot be used in some kind of the core networks. Okay, just to enhance the network components so that their performance will be increased, the quality of services can be improved in LTE as compared to 3G or as compared to 2G. Okay, so therefore, because of some of the implications related to your service providers, like we do have many service providers like Airtel, Vodafone, Geo, right? They are the service providers. Okay, and based on the implications of different service providers, okay, it was not possible for the other users to connect in a network. Okay, so therefore, just by upgrading the network architecture to LTE rather than using some kind of 2G 3G, we need to upgrade it. Okay, so your LTE is an upgraded version of your 2G and 3G. Okay, and why we have done that? So that there should not be any kind of implications related to the services provided by the other network. Okay, now if you look at this particular block diagram, we have the UE, which is nothing but usually this UE belongs to your mobile phone. Okay, we call it as the technically we call it as a user entity or user equipment, or simply it's a mobile terminal. Okay, and that particular mobile terminal will be always in roaming, right? Okay, or it is a mobility, it can be portable. Okay, there is UE. we have E node B in X2 interface. Okay, and you can see here this X1 interface and the X2 interface, what we have seen in the previous videos, that the X1 interface, sorry, X2 interface is with respect to the intra type of radio access, and or intra communication you can call, or and the S1 interface is with the inter. Okay, so in the sense, if you want to have the connection beyond the cell, outside the cell, you need some kind of protocols. Okay, and if you want to have some kind of the radio access channels within the cells, then you may also have some kind of interfaces. Okay, so that S1 and S2 interfaces are responsible for interconnection. You can see this is one complete cell, if I assume. Okay, and in that particular cell we use only X2 interface, not S1 interface. Okay, now but if I want to go beyond to some other cells, then I may come across with S1 interface. So in this way we try to connect a network here. Okay, so that the E node B in this particular uh, in this particular architecture, okay, which is also called as a base station. Okay, or simply call it as an exchange, right? So E node B can also act as a base station, or it can simply can be an exchange. Okay, and why that is used here is nothing but it is only used, okay, which where we can go for the termination of the air interface protocol, and it is the first point of contact to the user interface. Okay, what we see here a normal mobile tower. Okay, so our call will not be directly connected to another call. Okay, it goes via the tower, then we go to the exchange. Okay, then there is one proper hierarchy is maintained. Okay, so similarly this E node B is also responsible for your air interface protocols, and also it is the first point of contact where the user entity will come in contact with the base station. Okay, and other than E node B, we do have some kind of logical nodes. Okay, and that particular logical nodes are using some kind of functions related to your RNC, that is radio access control. Okay, and of UTRAN. Okay, and also this E node B is also responsible for your radio barrier management. Okay, then it is responsible for your uplink. It is responsible for the downloading of the dynamic resources which are already given by the resource management. Okay, and we know this LTE is completely a packet switching data. Okay, so therefore everything will be in terms of packet switching, scheduling, and also the mobility management. Okay, now other than that, we have some kind of uh, other terminals here, which is nothing but MME. If you look at this particular cell here, it is mobility management equipment or mobility management entity. Okay, so this mobility management entity is the, what this will do is it is responsible for functioning of your control plane. What again, it is related to your module number 5, where we have seen what is the use of mobility management. Okay, and this mobility management will support your GPRS nodes. Okay, and it manages the mobility, it's moving of your cell, moving of your mobile user from one point to another point. Okay, in such a way that there should be some kind of proper selection of your gateway, through which gateway I should send my call or I should receive the call. Okay, and also it is meant for your tracking of area. Okay, list management. So we have another point here is serving gateway, and this particular serving gateway is again useful for the interfacing with respect to UTRAN. Okay, if you look at this particular figure here, okay, in this figure it is serving gateway. Now if I want to connect my one cell to another cell, this serving gateway will be very helpful. Okay, and this serving gateway will connect your EUTRAN with this EPC. Okay, if you want to have the connection between this, you need to have the serving gateway. That is what it is responsible for, it is meant for. Okay, because apart from the logical mobility, you may have some kind of other mobilities also. Okay, where you will become across the handover operation, and then inter 3GPP mobility. Okay, and some kind of some lawful intercepts. Okay, charging of your mobile equipment if they are in roaming. Okay, and some kind of policies. Okay, and we have seen a list of policies which are meant for the LTE. Okay, so therefore this serving gateway is responsible for this particular interface. Then next we do have packet data. So this packet data network gateway, it terminates the SG interface towards the packet data network. Okay, and it is also responsible for your routing of data packets between the EPC and the external PDN. Okay, so if you have some packet data network outside the cell, then this particular packet data network gateway will help you to connect between those particular two different cells or two different blocks. Okay, and we have X1 interface and X2 interface. We have studied in detail about how this X1 interface and X2 interface are responsible, because we have the LTE structure where we have a user plane and we have a control plane. Okay, and that particular user plane and control planes are being splitted in or divided into the S1 interface and again the X2 interface. Okay, and this S1 interface and the X2 interface are responsible for the communication between your inter and intra cells. Okay, based on that rules, okay, the complete network architecture is all dependent. Okay, so here you can see we have UTRN. This is external, this is also external. Okay, and if you want to have a connection between this, you should have some kind of S1 interfaces. Okay, we have S12, S4, S3. The numbers have they have just given the numbers where there is a connection between the other cells. Okay, but major part will be here S1 and X2 interfaces. Now, other than this particular network architecture, after studying the network architecture, we may come across the radio interface protocol. Okay, and these radio interface protocols are nothing but, again, they are dependent upon the control plane and the user plane protocol stack, what we have seen in the module number 5. Okay, so based on that particular layers of the LTE, which falls under the category of the layer 2. Okay, so that layer 2 protocols are again divided into your different categories. Okay, so here we will see one by one how the radio interface protocol is composed, how it is designed. Okay, so the very first is the RRC. Okay, so RRC is one of the important part of your LTE sublayer or the stack, right? We have only three important topics there. We have PDCP, we have RRC, we have MAC, or it can be RLC. Okay, the first was radio resource control. What is this radio resource control? Is the radio resource control layer. It performs the control plane functionality. You know, there are various set of control plane functionality like ciphering, deciphering, integrity. Okay, sequence number. Okay, 5 to 4 5 functions were there with respect to the control plane. Okay, so therefore the RRC is responsible to perform the control plane functions like the paging. There is a maintenance and the release of RRC connections, security, mobile handling, mobility, and quality of service. Okay, the another layer here with radio interface is the PDCP. Okay, we have studied in detail how this PDCP will be working. Okay, so based on that particular PDCP working, there is a huge list of functions related to PDCP. Okay, and again the PDCP is the another sub layer of your complete LTE part. Okay, now if you, again, it is responsible for your header compression, decompression, ciphering, deciphering. Okay, and also sequence number. Okay, it's a huge list again. So if you look at this particular figure here, so the first layer will be your physical layer, then we have MAC, we have RLC, and we have PDCP. So above this we have RRC. So RRC is only available in the radio plane, not control plane, not in the user plane. Okay, then this is the LTE radio interface protocol stack. Okay, so in detail, if you see what this particular protocol stack consists of, or how the packet will flow from layer to layer. This is the upper layer, from upper layer to physical layer. Just like your IP protocol, all will flow from the application layer to the physical layer, right? So therefore, similarly here also, the everything will fall under this particular layer wise. Okay, and what this each layer consists of, their own header. Okay, then your IP packet, which is of, it can be of 32-bit or it can be of 64-bit. Similarly, it go on extending. But what about here in RLC? Again, we have RLC header encapsulated in the PDCP header, and then we have IP data. Similarly for MAC, we have MAC header encapsulated in RLC and the PDCP header. Again, it is the whole stack. And the last is nothing but your transport block, where the whole data is merged into only one particular link. Okay, and if you look at into the various functions of the RLC, we have seen the various modes of RLC, where the ARQ, RARQ. Okay, we have seen the various mechanisms of mode, like we have transparent mode, we have acknowledgement mode, and we have unacknowledgement mode in detail. Okay, so those topics will fall under the category of radio link control. Okay, this TIA mode, it is one of the simplest mode, okay, without any RLC header addition, okay, data segmentation and concatenation. And this is it allows the detection of loss of packets and provide reordering, and the assembly and connection mode, where it is falls under the complex mode and is configured for retransmission. Okay, and we have studied in detail about the MAC. Okay, so MAC is again responsible for hybrid ARQ mechanism, like mapping between the logical channels and the transportation channels. Okay, and then we have seen the concept of multiplexing and demultiplexing in RLC PDU. Okay, so where the various formats are available for the MAC data protocol or data stack, and all those particular is done under the MAC sublayer. And another important thing here is the MAC sublayer is also responsible for transport format selection and of scheduled data or scheduled user entity. Okay, and the last layer here in the radio interface protocol is the physical layer. And the responsibility of the physical layer, or the function of physical layer, is the actual transmission and the reception of data. Same thing what we have studied in the IP data protocol, IP datagram, right? Physical layer. So physical means it just connect one physical layer to the another physical layer at some other connection point. Okay, and that physical layer is responsible for your data reception, data transmission, okay, in the form of different blocks, packets, and in terms of bits and bytes. Okay, and again, the physical layer is also responsible for various control mechanisms, such as signaling of H hybrid ARQ feedback, right? If the data is received, it will receive some kind of feedback. Either the feedback can be in terms of positive feedback, or it can be in terms of the negative feedback mechanism. Okay, and other than that, the signaling of the scheduled allocation and channel measurements are done in physical layer. So with this, the two topics of the one is the network architecture of LTE, okay, and the another is the radio interface of the other things is being done here in LTE system. Okay, so with this, I conclude this today's topic. Okay, so in the next video lecture, we will be seeing about how the hierarchical channel structure of LTE will work. Okay, thank you.